Good morning.
Good morning. Is it raining outside in your place?
Yeah.
All right, guys, welcome back. Do you have any questions? If you don't have any questions, and I'd like to talk about even function, odd function in this section, okay? Because sometimes we can get to use that property, okay? We could have used it actually in some of the exercise we did last time. And so I think this is about time, but we're still at trig 7. Okay, we're still at trig 7. You see, we jump from basic 1 and then we do some exercise at trig 7. But our focus is very much trigs basic 1, okay, all of those functions. And of course, we have covered them all. And last property, but not least, of course, not the least one, but theoretically speaking, okay, what is function? What's the even function? What is the odd function? Okay, even function, odd function. I want you guys to write down the definition on page number 2 of your notes, or from any textbook. You should have that. Okay, even function, odd function. Okay, even function is such f is even if f of negative x equals to f of x. For all x in the domain. In the domain of f. And f is odd, okay, is that. What does this mean? Meaning, okay, let's look at even. Okay. From functions perspective, okay, from functions perspective, what is f of negative x? And what is f of x? Right? What is f of x?
The output?
That's right. It's very much related to the input and output. Okay. So we know that function is a rule. You guys really got it. I'm really, really happy to hear that. When you think of function, you think of input output. You do. Okay. In the future, in multivariable calculus, you have, multiple input for one output, but it is still a function. It is still a function. Okay. And so that's common. So that's so throughout your mathematical studies, and we're really very much focused on function. A lot of those algebraic manipulations is because we're observing different aspects of the function. Okay, we're going to see more of this as we proceed. Okay, so now if we look at the perspective from, an input for a specific function f, we don't know what it is, right? And f take this, act on this function and produces an output. So this is the output. Okay, we know that if the input is x, the output is going to be f of x. And now we have f of a negative x. What does f of negative x mean? Well, f of a negative x, if x is take its opposite, and of course the input is going to be negative x, right? So when your input is when your inputs are opposites, your output stay the same. You guys see that? When the inputs are opposite, the output are the same. What does that make of a graph? Think about a graph. Of course, first of all, you can see this domain of this function will have to have both positive number and negative number, right? Okay. And what else? The input from number line perspective, if they're opposite, that means they are on the opposite sides of the number line. And they have the same output. So can we draw a picture according to this description? Okay, of course, this is if, right? If. So in addition to it being a function, we have one more, condition satisfied, then that will make it an even function. So can we draw a picture for that? Okay. So what I like everybody to do, okay, I want to give you just a little bit time to analyze the situation. I think you might be able to come up with something. What is even function? What's odd function? Just follow the words to see if you can picture what's happening. What's going on with even function? And then you start to identify what are those functions are even functions in basic one, right? In basic one, do we have some even functions? Right? So when we look at the word, when we read the words, or we think about the words, and we reflect on its implication as what do we know about functions, the different kinds of functions, and then we may have a picture of this. Anybody? Anybody want to say something?
Would it be like f of x is equal to x?
Well, what did you say? Would
Would the graph be like the function f of x is equal to x? Where the inputs are the outputs?
the function of f of x, like the picture of f of x equals to x?
Yeah.
How does the function of f of x equals to x look like?
It's like a diagonal line.
Sorry?
It's a diagonal line.
It's a diagonal one. All right. Any other comments? When inputs are opposite, the outputs are the same. Inputs are opposite and the outputs are the same. Okay. So your comment is that this function will make it, does it? Okay, so let me make some adjustment on the view. When input are opposite, well, this actually is implied whenever. Okay, this, even though it didn't say whenever, it means whenever, because it for, often for and whenever they actually mean the same thing here. Okay, so when the inputs are opposite, okay, so suppose we have an input, okay, for input, say x, okay, for input x. and this is x. Well, I think I'm going to have a different color for input. I'm going to use green for input. Okay. This is x, right? So this much is x. If this much is x, what is negative x? If this much is x, right? What is negative x? It would be on the other side, right? Because they are opposite. Okay. So let me try to draw that. They should be of the same length, and that's negative x. Okay. For x, there's an output. Okay. Let that output be red. Okay. So this is, and for this particular function, okay, the output, oops, why is still, come on, turn the color. Okay, I'm going to change the color. Okay. For this x, the output is y. This is negative. I'm sorry, this is f of x. Okay, this is f of x. Okay, and this part is negative x, and therefore we're going to draw f of a negative x. So this guy is f of negative x. They are the same. In this case, are they the same?
No.
They're not the same. So this function is not even. You follow me? Because if you draw f of negative x here, you should have get this guy. This is f of negative x for this particular function. Okay, so this is required. The two red are required for even function, but here we don't have that. Therefore, this is not even. Do you follow me? Do you follow me? Now, for even function, can you picture it now? Can you picture it now? Okay, I want you to write this. I'm going to clean this up. I want you to draw it again. Okay, I want you to draw it again. Okay, I'm going to remove this. I'm going to remove this line. So we know this example is not an even function, right? This is not an even function. So now you get the idea, right? So now I want you to draw again. According to the definition of even function, you're going to draw 2 points. Arbitrarily. Okay, you have free hand on this. I'm not going to give you, x must be 2, so on and so forth. You just use your imagination. You have so many choices. Yeah, you only need to give me 2. Right. This is analyzing. This is analyzing the words, derive its implication, reflect on the examples. A skill that is very much required, okay? Heavily required of your study in calculus. Okay, there are not many words. You see, there are not many words. In a lot of mathematical definition, you see that it's pretty condensed, but every word counts. Okay, so we have entered the next level of reading, which is analytical reading. analytical reading. Did you get it? I'm sure you did, right? Input. Suppose this is X, okay? For my convenience, I just, I use the tick mark, okay? And so this is X. I can call this X, okay? Don't get me wrong. And this will be negative X. Negative X does not mean it has to be positive or negative. You don't know. We don't know. Okay, if X is positive, negative X is negative. If X is negative, negative X is positive. Do you follow me? Now you need to have that kind of connection. Okay, X and negative X is just opposite, but they're in the same category. They're both inputs. Okay, we only have two major categories here: input, output. For these two input, right? What are the output? Okay, f of X, f of negative X. Okay, so this is f of X, and that is f of negative X. And they must be the same. That is required by the definition. So if this function is even, imagine how many different values X can be, right? Could it be that the f of X is negative? Sure, it could be flipping over, right? It could be another, say another input. I'm going to change the color. Purple. Okay, so this is the input. This is X, and that's negative X. Okay, so, and the output, this output, and that's the output. And they must be the same. And all of these dots, okay, this dot, and this dot, this dot, and this dot, many dots, they are connected. And that makes a picture. Of course, we don't have the function. We don't have this, you know, but what do you see? What kind of feature do you see from these four dots? We are about to identify which function will be even, which function is odd in basic one. So this kind of function, even function, has what kind of feature? I want to hear some special words.
A parabola?
Yes, parabola. Which parabola?
X squared?
Hmm?
X squared?
Yep. X squared is one of those. But you didn't tell me the feature. Your example is right. Okay, f of X squared is even.
When the exponent is even?
Exponent to what?
To function, x squared when the exponent.
Okay, you still are telling me which functions are, you're still telling me the feature, the name of the function, which is correct. Okay, x squared, x to the power 4, and so on and so forth. Very good. Okay, all of these functions are even. What I'm asking you, what do these all even functions have in common? If you look at the picture, what kind of picture will prompt you to think about, oh, this function may be even? What kind of feature do you see?
Symmetry.
That's right. That's the word. Symmetry. Symmetrical with respect to what?
The x-axis. I mean, oh wait, the
X-axis?
no.
Symmetrical, right? You have one here, you have the other one here. Okay. They're same height, same distance. With respect to what? What line is this?
Y-axis.
Y-axis. That's right. Even function has that feature. It is symmetrical with respect to y-axis. So with these, can we identify those functions that are even on table 1 or basic 1? Obviously, this is not the only one, right? Basic 1, we only have x squared. I didn't list x to the power 4. So x squared is even. What else is even?
Absolute value.
And this guy is not even, right? We have recognized even, not even. What else?
Absolute value.
That's right. The absolute value of x is even. What else? What else? You just go through every one of them, right? And the easiest to identify is by definition. Is x to the power 3 even? Is x to the power 3 even?
No.
That's what you mean, right? Cortland, x to the power 3. Is x to the power 3 even?
I said f of x to the f of x equals x to the power 3 is even. That's what I meant.
Okay. Do you have does it fit the definition?
Yes.
It fits the definition? This function actually is a very important function in calculus. You will get the you will get to see this function's importance in calculus 1. I think it's in chapter 4 or something. Is this function even? Observing a function is even or not can be done in different perspective. definition is one criteria. The visual, right? The visual, when you see symmetry with respect to y-axis, then you say, this might be even. Okay. And because the definition explains it, right? When the inputs are opposite, the output are still the same. That's the major feature. And that feature, that definition determines if the function is even or other forms. Okay. So is this function even?
No.
Okay, to know it's even or not, all you have to do if you go by definition, okay, you just have to compare. Okay, you just have to compare. Okay, you just have to compare if your input is negative x. Okay, what are you getting? You're gonna get -1 to the power 3. And multiply x raised to the power 3. -1 to the power 3 is negative, so you're gonna have x raised to the power 3. Okay, in this case, f of x is not equal to f of negative x because they're obvious, right? This is f of x and this is f of negative x, and thus it is not even. That's all we can say. It's not even. Okay, so this is the general steps to prove is even or not even. Okay, so let's look at the definition of odd. Did I write off? Why did I do that? Sorry about that. Odd function. Now I want you to look at the odd function. Okay, with the experience we just did with even function, can you picture what's going on with odd function? What are the features for odd function? What are the features of odd function? F of negative x. Okay, so I'm still going to draw this. Okay, you can still looking from the function's perspective, right? Obviously, the opposite numbers must be in the domain, right? But this time, f of negative x, f of x, these two numbers, okay, are opposite. Do you see that? These two output, this output and the other output, they're opposite as well. So whenever the input are opposite, the output are opposite as well. Do you agree with my summary? That's just another way to say the words. Okay, that is whenever the inputs are opposite, their outputs are opposite as well. You can say they're respective. Okay, so this is the mathematical way of saying that, and this is these are the words. So from what we have recognized, I want you to draw 2 points on this blank space.
When making the new Kentucky Fried Chicken sandwich, people asked how I felt about burger places selling fried chicken. I'd say that's none of my business. It's like making fried chicken. It's none of theirs. Get the new Kentucky Fried Chicken sandwich for
Bro,
just
no way.
$3.99. It's finger licking good.
How did we
Guys,
get
I'm not
that
ready for
noise?
video footage,
Someone,
I'm not ready for it. I'm not expecting it. Like,
I think someone's got their mic on and they're on their phone on accident.
It's an incredible card. You know what? I could just do the card.
So whoever's on your phone, yeah, all good.
thank you.
Please.
Okay. Okay. Okay, I see the comments, symmetrical to the y-axis and so on so forth. Okay, very good, very good. All right, so what happened in this situation? I want you to draw. Okay. I want you to draw 2 points, just like what we did with even function according to the definition. You got that, Mikhail? Mikhail? Okay. So I'm just going to give you a little bit of time and space to read the definition and use your analytical skill to draw that picture, to draw 2 points, just 2 points, okay? These 2 points have opposite inputs. The inputs are opposite numbers. And their outputs are also opposite. What kind of picture would that be? Well, we haven't finished identifying even odd function yet, okay? You can certainly look at the basic 1 table. Okay, you can look at the basic 1 table. But here we just use definition to identify, you know, any function that's even or odd. So how do we identify that? What does the definition tell us?
So when the inputs are opposite, the outputs are also opposite.
Okay, so what does that make in a picture? When input are opposite. When inputs are opposite, what happened to output? What are the outputs?
They're opposite of each other.
They're opposite. So when you put that in picture, what do you see?
Like a diagonal line.
Sorry?
A diagonal line.
Diagonal one. And this time we can say y f of x equals to x is odd, right? So this height, that's the output. And that's the output for what? For f of negative x. And there's another one, there's another output, which is for x, which is here. f of x. Okay, they're of the same height. They're the same height, and they're opposite. Are they opposite? One is a positive, the other one is negative. Could it be that there's something here over there's something down here? Of course, right? So you have picture either in the first, third quadrant or second or fourth quadrant. Do you follow me? And these two are the same. These two are the same. Okay, do we understand what is f of negative x, right? The negative sign is inside, outside. What difference does that make? Do we understand that now? Okay, so these two are the same. In the definition is telling us if we put a negative sign in front of this guy, it will be exactly this guy. That's what I mean they're opposite. Okay, so you're right, f of x equals to x, the function we studied earlier, that was not even, but it is an odd. It is an odd. Okay, so can we identify other functions that are either even or odd or neither? Okay, there's a third category in terms of even, odd, and there's a neither case. In other words, that function may be, I mean, this function, there are functions that are neither even nor odd, and that kind of function is neither even nor odd. Do such functions exist? Of course, these kind of functions do exist. Okay, each one of the functions in basic one, they can be classified into these three categories. Okay, so I want you guys to go down the list to identify more even function, more odd function, whichever way is easier for you. So what do we see when we see odd function? And why, f of x equals to x certainly is an odd function. And we just work with x to the power 3, right? Is it even or odd? X to the power 3. Is it even or odd?
Odd.
It's odd. Okay, it's odd. It's not, it was not even. Okay, so continue down the list. Now I want you to look at the trig functions. Okay, we don't have a whole lot of time to go through everyone. Okay, this will be left for you. Okay, let's look at the trig functions. Let's look at the 8 trig functions. Which one may be even, which one may be odd, and which one is even, which one is odd.
Is cosine odd?
Cosine is odd. Okay, we got some contribution. Cosine tangent is odd. Okay, so we got some statements. Okay, I'm just gonna copy this. Okay, we're gonna judge. Okay, we're gonna judge the statement. Cosine is odd, tangent is odd. Cosine x. Is this a cosine x? And you think it's odd? Tangent.
No, cosine's even. My bad.
Huh?
Cosine's even.
Cosine is even.
Yeah.
That's right. Okay. Cosine is even. Okay, you see, it's symmetrical, isn't it? Symmetrical with respect to the y-axis. Right? Symmetrical with respect to, how about tangent? How about tangent? I really encourage you guys to play with these. Okay, we cannot do everything to the greatest detail possible. And we just pointed out, okay? And I hope you guys will study some more. Okay, you'll study some more of it, you know, after class and your spare time, when you're doing something, you think about these functions. Okay, it's really doing math is really about, it's a thinking process. It's a thinking process. Okay, cosine is even. Okay, so cosine function is even. Is even. Okay, can we see that? We can see that, right? For any input output, for example, if the input is the opposites, just look at the opposites, right? Just look at the opposites, right? The input, right? And this is another input, right? They're opposite and the output are what? That's their output. The output is the same. And this is true for every possible input. This is true for every possible input. Is that true? And those dots, you see there's a dot here, dots there. These two dots, can you mark these two dots? Can you mark these two dots?
Arc cosine would be odd, right?
Arc cosine will be
arc
odd.
cos. Yeah.
Is that what you're saying?
I think it might be neither.
Okay, so we leave that question. Okay, so what's that question? Did you say arc cosine is odd?
Yeah.
Okay, I'm not going to comment yet. Okay. The statement. Arc cosine is odd. Is odd. Okay, I'm leaving this as a questioned statement. So do you see that every point, okay, every point on the curve, okay, so whenever you have a point here on this side, you have another point opposite on the other side. They're symmetrical, okay? So the word for in the definition really means what? It means whenever. It means whenever. Okay. All right. Cosine is even, confirmed. Okay. You can also see this from the perspective of a unit circle. You can look at from the definition from unit circle. Okay. I will take you guys there after the picture, after this picture. Now, tangent is odd. Is that correct? Is tangent odd? Is tangent odd? Is tangent odd? This piece look like it, right? And how about this piece? You have something here. Do you have something on the other side? Right? Now you have something here. Do you have something on the other side? The answer is yes. The answer is yes. Okay, I'll leave you guys to study. These two statements are correct. So now let's look at, is arc cosine odd? Is arc cosine odd?
It's odd.
Arc cosine is odd.
No, our cosine is not even or odd. It's neither.
Very good. Can you show us something? Can we see that from the picture? Arc cosine is entirely above x-axis. It doesn't have the negative part. Okay, so it is true. It's neither even nor odd. Okay, so this comment is false. Okay, so arc cosine is neither even nor odd. Okay, so you guys can see this from the picture. You guys can see this picture. All right, so I'm going to go a little faster. How about sine?
Sine is
Sine is
odd.
even.
Sine is even.
Yeah, isn't it the same as cosine?
I'm sorry? The sine is even.
Yeah, I think sine is even.
Okay, sine is even. I put a question mark. Can you show me how sine is even?
It's symmetrical.
Is it symmetrical?
It has negatives. Well, if you put yeah, well, if you put what's it called, sine, a pi over 4, and it's called, it'd be the opposite to what's it called, negative sine, what's it called, pi over 4.
Can you type it? And Kyle says sine is odd. So we're debating between even and odd. Which comment is correct? Sine is odd. Okay. Well, it seems we have more comments about sine is odd. But there's still, we need to convince, right? This is not about popularity. This is not a popularity. And I want to say, yes, the answer sine is odd is correct. Sine is not even. Why? You can see it's not symmetrical. It's not symmetrical. Do you see? If you have this piece, if it's even, you should have another piece over here, right? Do we have that? We don't. Okay, but the question is it odd? Is it odd? The requirement for odd has to be very, very restrictive. Okay, you have your input, right? You have your input here, opposite input, and the output has to be opposite as well. So this output and that output they must be the same height, just opposite in sign. Okay, they're just opposite in sign. So sine indeed is odd. Okay, is that clear, guys? It's not even. It is odd. Are you guys with me?
Yeah.
Okay. And next, you can study this about, cotangent, secant, cosecant. And next, I want to show you from the perspective of the unit circle. The perspective of unit circle also tell us something about it. Okay, the perspective of unit circle also tell us about it. Okay, are you ready? So look at your unit circle and think about the definition of sine, cosine, tangent and cotangent. Okay, and I'm gonna find my unit circle and then bring it up. Okay, this study we're not gonna make it too long. Okay, unit circle. So first, let's look at sine. Okay, let's look at sine first. We go by definition. Right? So opposite angle. What are opposite angle? ARD. Right? ARD. Let's look at some special angles if you want. Right? If this is, I'm gonna use a different color. Maybe I'm gonna use a blue. Okay. This is obviously pi over 6, right? Sine pi over 6 is half, right? What is negative pi over 6? This is a negative pi over 6. Sine of negative pi over 6 is negative half. So opposite angle, opposite ratio. Do you guys see that? It's all in there. It's all in this unit circle.
Okay, that's so easy.
Does that make sense?
Yeah.
And this is true for every opposite angle, right? So this is because this direction
Same as that direction.
is pi over 6, right?
Yeah.
I mean, I just want you guys to just go, you see how important the ARDs are. Do we recognize how important ARDs are?
Yeah, so much.
So important. Okay, and you don't have to look elsewhere, really. You don't have to go elsewhere. You don't have to, so, I'm gonna have to remember 10 other tricks. Not at all. Okay, not at all. You see, angles are opposite and the ratio are what? Opposite. They're right there. And this is true for every special angle and non-special angle. Recall quiz number 4. If you go back to quiz number 4, for non-special angle, you will draw the same conclusion. Remember, I gave you terminals in 4 quadrants, didn't I? That special triangle 3, 4, 5. Do you guys remember that? And then you say, what if the terminal is in the next, what if the terminal is over here? How do you measure those angles? And this will be the positive angle. And that will be the negative angle. You follow me? And the ratio, that blue number, they're opposite. Yes? So this unit circle tells us even, odd as well. Doesn't it? Do you see that?
Yes, it does.
Do you have to remember a table and bang your head on the wall?
No.
Sine is odd, the cosine is even.
No.
Not at all. Do you need to do that?
Oh, damn.
Not at all. Has it become easier?
A lot.
I'm glad to hear that. Okay. Focus and know what to focus on, where to focus on. The focus is what? ARD. Can we repeat what I just said?
ARD.
ARD. So what is A? A is about angle measurement, right? How are angle measured? Very simple, isn't it? You definitely have that in your mind, in your head, in your running in your blood. If I'm asking you guys to draw a pint of blood today, in your blood, you know angle measurement. Okay, you will see ARD running in your blood. Okay. Angles are measured in radian or degree. It actually doesn't matter. It doesn't matter what kind of unit you measure it with. Angle is about whether how you get a positive angle, how you get negative angle. That's right. That's angle. That's A. And what is R? What is R? Reference angle.
Reference.
Reference angle. How is reference angle defined? How is reference angle defined? The acute positive angle between the terminal and
You I? Wait, no, the x-axis.
and the x-axis. You just have to focus on these three definitions and everything will give you, everything will come from it. Yes, every angle is measured from standard position. You have to know what standard position. Didn't I quiz you that before? Quiz number 4. Everything you need to know about trigonometry are in ARD. Okay? Of course, we haven't, we're not finished yet. So you can see from that unit circle, you can also see even odd. You can also see even odd. So now let's look at cosine. Let's look at cosine. Okay. So sine of negative A, this is equals to, you can write it any way you want, really. Okay. And A is any angle. It doesn't matter measured in degree or radians, really. I want you to use radians because you will be using radians only in your future classes. But it's not going to make any difference if you work with degrees. Okay, it is any angle. Only real number. Okay, so are we ready to look at a cosine? Okay, so let's look at cosine. So let's look at cosine. Okay, cosine. From this picture, you're going to observe cosine A and cosine of negative A. Right? And how do we draw the angles? Same way, ARD. Okay, A. So now let's draw the terminal, right? So this time I'm going to do this one for change. Over here. Okay, of course, this is a pair of pi over 3, negative pi over 3, right? These two angles are opposite, aren't they? Aren't they opposite? Yes? So this is A, and this is a negative A. Right? And what happened to the ratio? What happened to the ratio? Look at the red number.
Stay the same.
Same. Because these red numbers are the cosine ratio, right? Are the cosine ratio. So when the angles are opposite, the ratio are what? Same. And are these the same if you have angles ended up in the second and the fourth, second and third quadrants? Of course. Of course. Did you guys get it? So you see symmetry. You see symmetry on unit circle as well. On unit circle as well. They're consistent. They're absolutely consistent. They're absolutely consistent. Okay. So now let's look at tangent. Okay. Let's look at tangent. Okay. So here, that's the cosine. So A is any real number. Let's look at tangent. For tangent, you can look at, you really just look at the ratio. You really just look at the ratio, right? Because tangent is a blue divided by the red, right? Blue divided by red is tangent. You still look at positive angle, negative angle. Are they opposite? Take an example. Take an example. This pair. When you divide the blue by the red, do you get the same number or you get an opposite number? You get opposite number, right? When you get 1 and the other one's -1. So this also tells you this tangent is odd. If tangent is odd, how about cotangent? If tangent is odd, how about cotangent? Right, you need to think about this. It's a cotangent. Cotangent is red divided by blue. Right? Cotangent is odd as well. If sine is even, how about cosecant? If cosine is, if sine is odd, how about cosecant? If cosine is even, how about secant? These are the questions I want you to think about. There are only 6 functions you need to think about even, odd. Of course, you say, how about arcsine, arccosine, arctangent, arcotangent? I'm really going to leave some space for you instead of giving you all the answers, because you have all the tools you have. You have all the tools you have. You just have to take take yourself to go that extra, extra thinking. Okay, so now I want to go back to talk about how do we express algebraically, right? We know that tangent is even. Tangent is odd, right? So tangent of negative A equals to negative of tangent A. Okay, these three forms, okay, that is how we express them mathematically. These are how we express them mathematically. Okay, so I'm going to write it down again for you. Okay, so you not only have to understand the picture from different perspective, from definition, you also have to see and recognize and be able to use the algebraic form. Okay, so sine is odd, meaning that's what it means sine is odd. Okay, you simply just do f of negative x equals to f of a negative of f of x. Do you guys follow me? Do you follow me? F of negative x is negative of f of x. That's odd. That's a definition, right? For all the, I'm gonna use some shorthand notation for all the x. Okay. And cosine is even. You basically write a cosine. You can use x if you want. Okay, that's the even. So I'm gonna put a 4. Okay, so 4. Over here. Okay, that's for even. And tangent, these are the algebraic form. These are the algebraic form. Okay, so tangent of negative a is negative 10 of a. Okay, for all of that. So these are the algebraic form you would write. Okay, so you got a picture, you get definition, you got unit circle, you get all of these different forms. Got it? So now let's come back to trig 7A. In a variety of places in trig 7A, we could have used these properties. Okay, we didn't get to talk about it last time, and today we can. So I'm going to take some questions, and then we're gonna have to move on. Okay, we should wrap this up. We should wrap this up today. For example, okay, one of the exercises we did yesterday. Now, back to trig 7A. Okay, for example, this question, arc cosine. Arc cosine of, I think we did this question, negative 3 pi over 4. I'm sorry, cosine. Okay, I got it. This question is question number 18 on trig 7A, number 18. I forgot we did this one, exactly this one or not, but it's very similar. This question, we did it, other ways. You could also use even function property. Okay, this guy is even. Therefore, you can just write arc cosine right? Over here, cosine 3 pi over 4 is the same as cosine 3 pi, negative 3 pi over 4 is the same as cosine 3 pi over 4. And then you use that property, it just equals to 3 pi over 4. That's it. Okay, so this step you use even function, cosine x is even. And the next step, which property did we use? And here we use this property, arc cosine x equals to x if zero is between x is between 0 and pi. Right, you can see even function, odd function sometimes is very useful. It really, you know, you of course you can use a definition. It sometimes give you a little shortcut. Okay, sometimes give you that little shortcut. But anyway, do you guys have any other questions? If you don't have any questions, I think we have wrapped up basic 1. Finally, basic 1. Are there other things we want to cover? Of course, the trigonometry, there are a lot of stuff. Okay, just all these different aspects of ARD. Okay, all these different aspects of ARD. But now we have a closure. We have a closure on these on basic 1. Okay, and of course our exercises, I give you the pointers to different directions. Since we are at a trig 7a, okay, I would like to just go one more step, and I will take you guys to trig 8. You ready? Trig 8. Okay, trig 8. What about trig 8? Trig 8 is I think is if you probably have seen this in trigonometry. I'm sure you have seen this in trigonometry. Okay, for example, you'll be asked to work out these kind of questions: cosine, arc sine x. Okay, the type of question in trig 7a and trig 8, these kind of questions you will be used to you know, to very you're going to be used quite a lot in calculus 2. In calculus 2. Okay. Sometimes you have a number here, sometimes you don't. Sometimes you have a number here, sometimes you don't. So when you see here in trig 7a, you will see you're given a number here. But in this case, you're not given a number here. Okay, it's just x. And what do we ask to do? Okay, it says write the expression. Write the expression. Okay, this is just an expression. This is a statement as an algebraic expression in X. Okay, and I'm not going to copy the whole sentence. Basically, you're going to have to rewrite this expression as an algebraic expression. What is algebraic expression? The algebraic expression meaning you no longer have these trig functions show up anymore. The trig function will disappear. So your final answer should not have any trig functions involved. That's what it meant. Okay, and how do we do this? How do we do this? You're just working between ARD, DRA, ARD, DRA. That's what you do, right? So in order to complete this question, you need to understand the process. You need to understand this process. This input is given to what? Okay, so I'm going to put this as a think out aloud. Okay, you typically, you don't need to show this to your teacher. Okay, your professor don't need to see this, but you need to understand this. Right? Remember, we emphasize arcsine is a function takes what kind of number as input? Takes ratio as input, right? And what comes out?
Angle.
Angles. What kind of angle? The angle has a boundary, right? It has boundaries. It cannot be any angle, isn't it? Now, what is it?
From -1 to 1.
From -1 to 1? So the input is ratio. The output are angles. You get that right. Go check your notes. Go check your notes. This is not a test. I'm not testing you. Okay, this is not a closed book exam.
Is it from -π/2 to π/2?
That's right. Okay. Look at the pictures. Look at the pictures, right? It's all in the picture. And it's also in your in the unit circle, isn't it? Right? We have all these different perspectives. And what are the specifics? What's the special requirement about the input? Right? So this as the input, X as the input. Okay, I'm going to put this specifics underneath in the next line. Okay, and then this number as an angle is going to give to cosine. So this output from the first layer is given to the next layer. And it comes out. It comes out. And this quantity comes out is an angle or ratio. Is it angle or ratio? This is ratio. Ratio give to arc sine. As long as that ratio between -1 to +1, it comes out as an angle. This is where the angle is going to be. And this angle is given to cosine. Cosine take that angle. So what kind of quantity comes out at the final output? Is it ratio or angle?
The ratio.
That's right, ratio. You see, that's the first thing you need to understand. Okay? I have seen a variety of mistakes in the past. When I was looking at the students' work, they have no idea. This is the first thing you need to understand, how this function operates. Domain range. You have to be fully aware. We have to be fully aware. Okay? And this ratio has to be between what? This ratio has to be between what? It's going to be between -1 to +1. That's the range of cosine. Cosine can take any angle. So this is the picture. This is the thing you need to understand. In your head, it has to be there. With that understanding, then you recognize, oh, this is going to give me an angle. So you're going to assume this is going to be an angle. I often see this mistake. A student will do this. What kind of junk is this? What kind of junk is that? Right? I'm not pointing to any particular person, but this is the kind of mistake I saw often. You're telling me the input is the output is the same as the input. Is either the input is ratio, the output is ratio. What kind of junk? This shows no understanding of this whole process. Is my judgment harsh? Right? Is my judgment harsh? Nothing personal, nothing personal. No understanding, no understanding. That's what we're here for. We're here to enhance understanding. Okay, we're here to enhance our understanding. There's no personal things here at all. Okay, so don't do that. So now I think we're about to continue. We know this is an angle, and this angle is where? This angle is in the interval between -π/2 to π/2. Right? So your cosine, so when we work with the cosine, what cosine of this angle? Cosine theta is desired, right? Cosine theta is desired, is wanted. Cosine theta is wanted, right? So this is how we analyze this question. Okay, you need to have scratch paper to scratch on, and you know, you just have to give yourself that kind of space and room, and the paper to work on, scratch paper to throw away, that kind of thing. I'm not asking you guys to cut down more trees. Just look around your house. I'm sure you're gonna, I hope, you know, You're gonna find some paper laying around there. We don't need to cut extra trees, but we do need some scratch paper to work on. Okay, and some of you may have the iPad. You can just scratch on. That's good too. That's really green. Okay, but anyway, so this implication. Okay, so from here we also can figure out that there's this relationship. Tell us what? They tell us sine theta equals x, right? That's the definition of, so sine theta equals to x. So from sine theta equals to x, what you do? You first understand the input-output relationship, right, which is dictated by definition. When someone tells you sine theta equals to x, what does that tell you? Okay, I'm gonna bring that my rectangular coordinates right here. What does this tell you? We go back to ARD. We go back to ARD. ARD again. What does it mean sine theta equals to x? And this angle has to be between negative pi over 2 or pi to pi over 2. Right? So basically you measure an angle. This is angle theta. Well, of course, it could be the other one, right? It could be in the fourth quadrant, either first quadrant or fourth quadrant, right? So that's your theta. Okay, could it be another case? Of course. Do we have another case? Either one could be the theta. Do we have a possibility that the terminal in the second quadrant or third quadrant? Impossible. So you think of these two cases, and then you draw the terminal, you draw the triangle. It tells you sine theta equals to x. What does sine theta equals x means? It tells you basically sine is defined as this is x, right? And this is 1, right? And what would that be? Cosine theta is what? This is a cosine theta, right? It will be adjacent sides over hypotenuse. So this piece of information, if you go back to definition, go back to ARD. So the whole thing in the process, we're using ARD, don't you see? Do you see? ARD. Okay, so what is this side? What is this side? It doesn't matter which one, right? What is this side? Pythagorean theorem. Right? 1 minus x squared. That's a cosine theta. And cosine theta is wanted. Cosine theta is wanted. Okay, so we're almost running out of time. Let me summarize what we just analyzed and put it together as a, as a piece of work. You turn it in. Okay, I'm gonna turn it into you. Okay, I'm gonna turn it into you. Did you write it down? Don't worry, I will do it again. Okay. To work out this question, this is just a statement. This is not an if statement. This is just a statement. Okay. Work for that solution. Okay. You say let arc sine x equals to theta. And of course, we know that this theta is between negative pi over 2 to pi over 2. So for your reader's convenience, you point that out. And of course, it also show off, you know this, you know the domain, you know the range of arc sine. When you show your work, it doesn't hurt to show off a little bit and show off nicely. Okay, show off nicely, organized, show your best work, in other words. Okay, then you can say thus. Okay, whatever words you like to use. Okay, thus you say, then sine theta is equals to x. Okay, and then you can attach that little picture with you. You can attach that little picture. Okay, so you can draw a little picture here. Okay, the terminal. This is theta, right? And of course, it could be the other line. It could be the other line, really. Okay. So you have shown your reader, you really understand this process. Okay, it could be theta here. It could be this could be theta as well. Okay, but you just work on one of them. Forget the tick mark, because this tick mark they should not be there. I don't know how to remove them, so don't worry about it. Just pretend we don't, we don't see them. So this is x, and this is 1, and this side, okay, you can put it outside if you want, or I can do this. Okay, I'm going to do this. So this side, I'm going to use, I'm going to just make it nice. I want to give you a comprehensive piece of work. And that is going to be square root of 1 minus x squared, Pythagorean theorem. And it's in the first quadrant, of course, it's a positive. And then here, you can say cosine. I'm sorry, I'm making a mess, okay? But hopefully I will fix it. Sine x equals to cosine theta. And that equals to that guy. Right there. Okay. There. Well, these terminals is a little bit off. And I'm going to make some adjustment. Okay. Do you understand what I mean here? Does everybody understand? Okay, so how much work you need to show? I think this much is enough. Have a little picture attached to it, even though that's optional. But since you're drawing that picture anyway, you need to be able to do this. You need to be able to do this. Let me say it again. You need to be able to do this for Calc 2. Okay, in Calc 2, sometimes you may have a number here. Okay, sometimes you may have like a 3/5 here. Okay, -½ things like that. And you need to be able to handle it. You need to be able to handle it. Okay, so I think that's all for today. And I want you to continue to work on Trig 8. After Trig 8, we're going to take a break from trigonometry. Okay, so I'm going to do back and forth. Each time we're going to, my goal is that we're going to review trigonometry a couple times. Okay, this is obviously the hardest topic. So Now we have done all the functions, and next we're gonna get to the, the different parts. We're gonna get to the different parts. What I'm hoping is that for those difficult part, hard part, we get to do it over and over. We're gonna do it over and over. So each time we review, not to the same extent, but always review those key elements, okay? So also give you reason to go back to watch those lectures and so on and so forth. Okay, and I will see you guys tomorrow. Okay, keep on with your good work, very good work. Today, the participation is amazing, and whether you have you have spoken or you type it on the chat, and that's all very welcome. These are very, very good contributions to the classes, and I really, really do appreciate it. Okay, it makes my class more interesting. It makes me feel more interesting because we have some interactions. Okay, I'll see you guys tomorrow. Have a great day. Stay dry.
Have a good one. Bye-bye.
Bye.
Bye-bye. Thank you.
Of course. I'll see you tomorrow.
Bye.
Bye. I'm heading to the office hour.